under the patronage of Lieutenant General Sheikh Saif bin Zayed Al Nahyan, UAE Minister of Interior and Deputy Prime Minister. The General Headquarters of Civil Defense presents the 5th Annual Fire Safety Technology Forum, UAE.
On September 16, 1990, a 300-foot-long oil tanker called the motor vessel Jupiter caught fire while docked on the Saginaw River in Bay City, Michigan. The Jupiter carried more than 1 million gallons of gasoline. As different sections of the vessel started exploding, the crew abandoned ship. The river was only 1,100 feet wide and lined with oil refineries and single-family homes. If the tanker broke loose and ran aground, it could kill hundreds of people. As the fire burned through the night, the punishing high temperatures were buckling the Jupiter's hull. The local fire department didn't have the proper equipment to handle this kind of emergency. Williams Fire and Hazard was called in. By the time they arrived, the fire had been burning for 18 hours.
The Jupiter was still a live ship when it caught fire, and when we arrived, the engines were going, the generators were still going, and that is still a source of ignition as long as the vessel is live. As we approached the vessel, we started putting on our cooling streams. Had all our pumps fired up, cooling streams going, and what we want to do is cool off all the steel, because at this point the fire had been burning some maybe 18 hours.
Using high-grade foam, Dwight and his men were able to knock down the flames almost immediately. A fire that burned over 18 hours was extinguished in less than 30 minutes by the Williams firefighters.
August 1999. In Wortham, Texas, an oil pipeline explodes into flames and burns out of control for several days, overwhelming local firefighters. Specialists are called in. They put out the fires in 3 hours. May 2000, Eunice, Louisiana. A chemical freight train derails, setting tank cars of hazardous chemicals ablaze. Others are set to explode. The town is evacuated. But experts arrive, and in a few hours the fires are extinguished, a major crisis averted. It would be put to the test on July 24, 2000. Williams responds to another SEAL fire on a 100-foot, almost 30-meter in diameter tank in Sealy, Texas. Clear from the firefighters' video, walking on the floating roof was out of the question.
The rubber seal that goes around the circumference of the lid, or the roof, the floating roof, has burned away and is now exposed. The crude oil in that area, and that's where it's catching the air, that's where it's burning. A seal fire left alone will burn a long, long time. The biggest motivator to put it out is environment. We don't want any smoke in the air. This particular town on that fire had been evacuated. It had now been burning some 11 hours. Their biggest question for us is, when can you put this fire out?
70 rungs up, Chauncey headed for the platform of the crude tank containing 80,000 barrels of hot oil. Flames jumped 20 feet above the seal.
We actually rigged up on it, got foam flowing, and they ran about 10 minutes while we continued rigging the Despot Tool. And then as you see us bring it into the tank, from that point on, if you count, the fire is out in less than 2 minutes, and we never left the platform.
Thanks to the Despot Tool.
June 7, 2001, 1 p.m. A brutal tropical storm batters America's Gulf Coast. While those in Texas and Louisiana fight flooding, the fierce weather brings other worries. Days of rain have broken the seals on a dozen tanks, sinking the protective roofs, exposing volatile vapors to the environment. It's a script for disaster refinery fire chiefs like J.R. Chittister of Orion know too well.
You can have a bad weather come in. You can have the possibility of a sunken roof. You could have one of your lightning strikes for a seal fire, or you could get your worst case scenario, which is a full involved tank fire.
Lightning strikes at 1:30 p.m. The horizon explodes 10 miles west of New Orleans, Louisiana. A gigantic tank fire rages at the Orion Norco refinery. Now, with the full attention of the media, this was a disaster like no other. At 270 feet, over 80 meters in diameter, containing about 300,000 barrels of fuel, Louisiana was witnessing the largest tank fire the world has ever seen.
My problem was I had a fire in my refinery, and my bosses wanted me to make this problem go away.
For the industry, this is a nightmare come true. The Orion fire chief knows early his crew needs help. In his 25 years of fighting fires, Glenn Durham has never seen anything like what awaited at Norco.
Nobody in the world had ever attempted to extinguish a tank that size. And what I told them is, I said, we're going to get one shot. We have the energy and the resources to try this one time, and one time only.
They will only have 65 minutes of foam to smother the fire completely. If a wisp of flame is left when the supply runs out, the fire will reignite and the tank could burn to the ground. It would be a failure that would haunt Dwight Williams for the rest of his life. 12,000 gallons per minute of water and foam hurl skyward into the tank. Without aid to see into the tank, Dwight has to be guided by instinct. He can only hope the foam cover would successfully build in time.
Keep in mind, you're throwing it, it's landing. It's running up against the back wall, and it's coming back, extinguishing the fire.
With the clock ticking off minute by minute, the crew waits.
It took approximately 11 minutes, 12 minutes into this attack where we saw that we were starting to get flame collapse and getting a bite on the fire. And a real great feeling knowing that, hey, this is working.
Foam supply was nearing empty, and the stubborn fire still surged. The threat of the entire tank reigniting loomed. Dwight's skill would now be put to the final test.
So we had a piece of fire about this big inside that tank. And we had to technique it out. I was getting a mental picture of what was going on in the tank. I was feathering the nozzle. I was everything that I could think of to put the application that would kill that ghost on that foam blanket. I was doing it. Chauncey was doctoring the nozzle just exactly like I wanted it done. "13
long hours after lightning struck, the skies above Norco finally go black. History was made. The largest petroleum storage tank fire in the world finally extinguished.
And when the fire went out, we had probably less than 7 minutes of foam supply left. That's not the first time we've got it with the last little bit of foam or the last whisper of dry chemical.
We did it. Was there, and you wish that everybody that you're associated with in your close circles in this industry could have been there with you to experience it, to enjoy it, to see what was done.
There was a lot of people that said we couldn't. And when we done it, just some serious bragging rights, because nobody had ever done it before.
There's something about extinguishing a very large fire that makes you realize just how humble you are in the grand scheme of things, how small you really are.
Okay, first I'd like to congratulate the team that you guys did with the torch towers. I actually saw it on Fox News channel in the States, and which I thought was really cool. When I see it, I said, you know, I know some of those guys who did that, so congratulations. Because for myself, I do not do any type of Class A, any type of structural firefighting. So that's, my hat's off to you guys. Very good job. What I want to cover, and by the way, the video was the first time I saw it last night, and I was looking at the bio. It's now over 30 years, and as they say, time heals all. I don't think my appearance is following that old saying. So, but where I want to go to with this presentation is just basically lessons learned of what we've done, actually the experience that our company has learned, how we're evolving in this industry. This here is an actual photograph of an oil field in Oklahoma. And take a look at it. The design, the concept of this was to use artillery in the event of a crude oil storage tank because of the boilovers. They would actually go and shoot a hole in the bottom of the tank, dump the oil into the diked area, whatever the containment area, the size of the containment area, in order to reduce the magnitude of the boilover. And actually it was MIT who came up with this concept to do this, and it was a fairly common practice. And even into the 60s, some of the refineries in the areas that we have within the states still had those cannons. Of course, they no longer used them, but they were more monumental to show of where we're coming from and where we've been. But we're constantly evolving. We never stop. For me, the significance of this photograph, this is MagPetco, soon to become Mobil, then from there ExxonMobil. This is about 15 miles from where I live, from my hometown. This was the first incident where Les and Dwight Williams actually worked together as a team. They're father and son, but Les was the fire chief at a local chemical company, Jefferson Chemical, and Dwight was an insulator at Texaco Refinery. The two guys worked together for the first time on this. Now, one of the questions that was asked to Dwight in one of the interviews that he did, I heard the worst fire, the most difficult fire he's ever been involved in, and that was that MagPetco fire. But what came from that from us and the understanding of the difficulty with it was this hydrofoam nozzle. This is one of Les's first patents that he put together in our industry. And what it is, it's a self-educting nozzle that will pick up its own foam chemical without any other means of pumping other than water, which is very, very critical for us because it reduces our logistics dramatically. So looking at everything that we've seen over the past 30 years in the flammable liquid firefighting side, this simple piece of equipment right here has probably done more for flammable liquid firefighting than our industry, than any of the products that we have available today. Navajo Refinery, 1982. There were two gasoline storage tanks of identical size-wise. They were 80 feet, 24 meters in diameter. The significance here are both of these tanks were mirrored of each other. They're exactly the same. The two different products that were utilized on it, one was a straight AFFF, utilized for foam. The other one was an alcohol-resistant AFFF, where even though we were not dealing with an alcohol or a water-miscible product, the alcohol-resistant tank went out faster. And that's when we started utilizing alcohol-resistant foams on large in-depth flammable liquids as opposed to AFFFs. And the reason that is because there is such a very large surface area that a straight AFFF, the drainage will drain too fast. And so that's the actual significance of this one individual event where we're going through. So we learned that the AFFFs, or the alcohol-resistant AFFFs, are a much better choice for that type of fire. We've also learned that larger nozzles were required because at this time, 500 GPM was basically the largest nozzle that we could utilize in the firefighting service. Tenneco Chalmette. This is a 150-foot diameter gasoline tank, 45 meters in diameter. If you notice also at the bottom, there's a dike fire involved with this, as well as the manifold, the product line that's going in and out of the tank. I'd say approximately out of the 180 tanks we've been involved in, 50% have fires burning at the base of the tank. That's difficult to control. If it's on the downstream side, we can normally deal with it of the valve. On the upstream side, a little bit more difficult to deal with. This is the first tank we utilized 1,000 GPM nozzles. So we went from 500 gallons per minute all the way up to 1,000 gallons per minute, or 3,700 liters per minute. And we also realized on this particular tank, because back then no tank larger than 150 foot was ever extinguished. The application rate for us per NFPA was 0.16 gallons per minute per square foot. And I apologize, I'm in gallons per minute and feet and not in liters and meters, but that fire took us 65 minutes to extinguish. If our application rate was correct and the duration was 65 minutes, even back then, Les was smart enough to realize something's got to change. Because as my fire increases in magnitude, either I've got to go with a higher volume of water foam solution or a longer duration. And it's basically we were not happy thinking that all we can do is make it go longer. Because in reality, if the tank, with that type of concept, I can use a garden hose and just take a week and a half to put it out. We know better than that, it's not going to happen. So we started bumping our application rates. I mentioned the dike fire and the fire at the base of the tank. This is Dwight Williams. On that particular tank, he's in an aluminum boat floating in gasoline with a dry chemical extinguisher to put that tank out. Now, trust me, that was not the first choice. Our choice is to pump water into the bottom if we can. We'll actually close the valve. The valve is in a failed closed position, so the valve closes off. However, the heat impingement on the flanges was on the upstream side of that valve. So there was no way to block that valve in to keep the fuel from coming out. Dry chemical would have been a perfect choice, but we were 70 foot from the dike wall, 10 meters or 15 meters, 20 meters from the dike wall to the tank wall. Dry chemical does not work that far. So he got an aluminum boat, put it in the gasoline, rode it over there, and shot it with dry chemical. From there, we developed a product called hydrocarbon. What that does, it allows us to shoot dry chemical further. It doesn't enhance the ability of the dry chemical. I can just shoot it further from point A to point B. We used to take a handheld extinguisher and actually put it into the stream and it'll carry the dry chemical. But what we're trying to do is get and make it as safe as possible. Let's face it, we're firefighters. There's nothing safe about the business. We minimize our risk, evaluate the risk, and we do the best we can with it. Similar to the torch tower the other day, When the call came in and the response would have been, well, we're sorry, it's too dangerous to respond. We can't tell them that. We evaluate our risk and we do the best we can. This is ExxonMobil in Baton Rouge. There were 16 tanks, 4 API separators, 2 pipe bands, and about 23,000 square meters of full surface fire. For us, this happened on Christmas Eve. The temperatures were below freezing, were sub-freezing for about 5 days. In the Gulf Coast of the United States, we're not geared for those types of temperatures, for those types of durations. So no water. We had basically no water at all to deal with. So all the water that we utilized was pulled out of the Mississippi River and the cooling towers. This is one of the 134-meter tanks. 34-foot diameter tank or 40-meter tanks that we had to deal with. We realized we needed larger volume monitors on this fire because as the hazards continue to grow, we get bigger and bigger and bigger. So our application rates grow, our application rates go up, the volume of foam concentrate goes up, and so forth. I've seen some of the tanks you have here. They're getting very, very, very large in comparison. This is Phillips Petroleum in Pasadena, 1989. Unfortunately, there were 23 fatalities in this incident. It was a valve that was plumbed in the wrong direction pneumatically. When they went to operate the valve, thinking they closed it, they actually opened it and dumped the reactive ethylene into the process unit. From here came the Process Safety Management Standard. We go back. The Process Safety Management Standard came from this. Trying to understand what it is that happened so we do not do it again. Are we going to mess up? Yes, I promise you we're going to mess up. But do we learn from our mistakes? Do we improve from our mistakes? And do we move forward? From there, the self-educting automatic style nozzles came into existence. And the rationale with that is when you have a major incident, all the water gets turned on. The operator's going to turn the water on, all your deluge systems are turned on, and then your water pressure begins to plummet. This type of nozzle will pull the volume back, keep the velocity where it needs to be so we can get cooling and exposure protection where it needs to go. Amoco, Texas City. This is a MTBE storage tank fire. This was only the second fire that I've heard of MTBE. The first one was also in the Houston area, coming out of a barge. That fire burned for 3 days. The fire was actually burning on top of the water. So this is it's a hybrid fuel, not quite a hydrocarbon, not quite a polar solvent, somewhere in between. The tank was 39 meters. We had knockdown in about 10 minutes, but it took us 3 hours to extinguish it. This was actually one of the, going in, looking at the tank, I thought it was going to be one of the fastest jobs we were able to do. But unfortunately, I think, as one of the presenters said earlier, I forgot which one it was, who said, be humble. This fire will make you humble. If you look, the entire tank height is about 15 meters. The foam at one time was 3 meters deep, and we had fire blowing through a 3-meter foam blanket during the process. And what did we take away from it? We took away that the standards for the MTBE product were not up to speed. The small UL, FM type, or EN type testing that was taking place did not replicate the problems we'd be associating with in the field. So we went and asked the industry to work with us, and that's what we did. We developed technologies, we developed different things to share with the industry on how to handle a situation if it arises again. This is a crude tank, a 70-meter crude tank in Louisiana. No seal protection, no fixed or semi-fixed system. We're actually walking down on top of the roof of the tank and fighting this fire with hand lines. Is that the safest place or safest thing to do? No, it is not. But currently we did not have any other options. So our takeaway from that, we understood that we had to develop technologies and equipment to combat facilities that do not have fixed or semi-fixed protection on their systems or on their tanks. I don't think that's a problem here as it is at home. But what you have to consider is some of the refineries we have operating in the U.S. are over 100 years old. Some of these tank farms are over 100 years old before many of the standards were developed. We still have a lot of the old riveted style tanks still in operation. We came up with a system called the Despot Tool, which is nothing more than a big clamp that clamps on the side of the tank. You can do it with a portable monitor, chain it down to the landing, whatever you have, but you're going to have to understand that many times things do not happen textbook. And the reason we have a fire, if you think about it, is because we've lost control. If we had control, it wouldn't be burning. So a lot of the things that we depend on, in fact, I was talking in the back a while ago, many times our role comes in when they push the button and nothing happens. If your engineered systems fail, what do we do? This was actually on one of the videos, the Tenneco Chalmette fire. We're taking that monitor, strapping to the side of the tank, and as Chauncey stated in that video, it took about 5 minutes to extinguish this tank. It looks a lot more dramatical than what it is. We've got a Sony camcorder looking down on top of the seal of that fire. It's not that hot. Of course, we wouldn't do it on a fully involved fire. But on this particular incident, we were able to put foam down on top of it because of what we've learned previous. So every incident, we are basically going and evolving. The problem there is I was the guy actually on the monitor, and it was a hand wheel type. A gear that you turn like that. The problem is my shoulders were hurting. And we learned that ergonomics was not that good for that type of monitor. Went back, changed the design of the monitor. Now it's a little bit better than it was last go round. This one here, the Orion fire, the largest fire to be extinguished, but we did learn some things there. 65 minutes. If we could do it again exactly the same way, I think we can have that fire out in about 20 minutes. From what we learned from it, the way the foam has to travel across the burning fuel surface, the temperatures of the steel that's around it. We also learned we need to look at lower percentages of concentrates. That fire was done at 3% concentrate. We were consuming 1,300 liters per minute. That's a cubic meter of foam concentrate about every 45 seconds. And so you go through a lot of foam. Well, it makes all the sense in the world to reduce the percent of concentrate so my foam now is lasting 3 times longer. You can see the burn line between the two. Actually, let me go back. You can see the burn line there, where the paint and the white and the brown come together. We didn't lose much fuel when we started. The fire did not burn out. We put that fire out. We saved, I think about 12 million gallons of product into it. So, but what we learned was on that particular fire is even though we were starting to use larger volume monitors, Unfortunately, the monitors we were using were all hydraulically operated, and we learned that we needed to use larger volume monitors that were a little bit more ergonomically for us to control. So, well, my time is up. I do appreciate the opportunity to speak, and during the short conference or the questions towards the end, any questions, or after the conference, I'll be available. Thank you very much.